Good morning, students. Today we will discuss about centrifugal casting. We have already discussed about sand mold casting and die casting. So now this centrifugal casting is a type of casting which is used for particular jobs. As the name suggests, the centrifugal casting process utilizes the centrifugal force developed by the rotation of the mold to distribute the molten metal into the mold. In other words, this is a process where the mold is rotated rapidly about the central axis when the metal is poured into it. Because of the centrifugal force, the molten metal is directed outwards from the center towards the inside surface of the mold with high pressure. As a result of this, a uniform thickness of metal is deposited all along the inside surface of the mold. During solidification, the impurities, being lighter, remain nearer to the axis of rotation. Greater accuracy and better physical properties of the casting are obtained in this process. So, in centrifugal casting, the mold will rotate about a axis. And as we know, if a body rotates about a axis, a centrifugal force generates. And this centrifugal force throws the poured metal to the outer periphery. And as this force has a constant value, constant thickness of metal was thrown to the periphery. So, we will get the casting with better physical properties and greater accuracy. The centrifugal casting method can be classified as follows: true centrifugal casting, semi-centrifugal casting, centrifuging. So, we will discuss about true centrifugal casting. In true centrifugal casting, the axis of rotation of the mold and the axis of the casting are the same. Axis of rotation of the mold and axis of the product is same. The axis of rotation of the mold may be horizontal, vertical, or inclined at an angle between 70 degree to 90 degree. Here, end cores are usually used at the two ends of the mold to prevent the splashing of molten metal. The central hole through the casting is produced by the centrifugal force without the use of a central core. So, here the cores are just used at the end to prevent the splashing of the molten metal. But we usually use cores to produce a hole. But here the central hole is produced because of the centrifugal force. No core is required. If the axis of rotation of the mold remains horizontal, then the casting method is known as horizontal true centrifugal casting. So, this is the diagram of horizontal true centrifugal casting. So, here one electric motor is used This flask is the mold to rotate the flask. The flask is supported by means of two bottom rollers, and on top of these rollers, this flask is rotating continuously. Bottom roller and top roller. In between that, the flask is fixed, and with the help of the motor, this flask is rotated continuously when, with the help of the pouring basin, the molten metal is forced into the flask. So once this mold is rotating, a centrifugal force will be created and the metal will be deposited at the end as shown in the figure. As shown in the figure, an outer metallic flask with rammed sand lining inside is used as mold and is rotated by two sets of rollers. I have already explained. A variable speed motor which is mounted at the end is used to drive the rollers. Through the pouring basin, molten metal is poured, and during pouring the mold is rotated at a slow speed. After the pouring is over, the mold is rotated at a very fast speed for even distribution of the metal and for proper directional solidification. Wall thickness is controlled by the volume of molten metal poured into the mold. Pouring temperature range between 1482 to 1649 degrees centigrade and speed of rotation vary from 50 to 3000 revolutions per minute. The vertical and the inclined axis through centrifugal casting methods use the axis either keeping vertically or keeping the axis at an angle between 70 to 90 degree. In case of vertical through centrifugal casting, the axis remains vertical. In case of inclined axis through centrifugal casting, the axis remains between 70 to 90 degree. Here the molten metal is poured towards the center of the mold bottom. Convenience in metal pouring and ejection of casting is obtained by vertical or inclined through centrifugal casting. But here the central hole produced is not truly cylindrical. This defect can be minimized by high spinning speed. So what are the advantages of centrifugal casting? Sound and clean metal casting are obtained. In most of the cases, cores are not used to produce a central hole. No need of separate gates and risers. Production rate is very high. Thin sections and intricate shapes can be easily cast. Inspection is simplified as in this casting, if any defect occurs, it is normally found on the surface of the casting. The casting have very good mechanical properties. The percentage of rejects is very low. So what are the disadvantages? All shapes cannot be cast through this process. Only cylindrical shapes or any intricate small thickness castings which are more or less of cylindrical shapes can be casted by centrifugal casting. Heavy initial investment is required for this type of casting. Its maintenance is expensive and skilled labor is required. Another type of centrifugal casting is centrifuging. This is somewhat different from true centrifugal casting. This is also known as pressure casting. This casting process is similar to true centrifugal casting, but in this case, the axis of rotation and the axis of mold don't coincide with each other. Here the molds are situated at a certain distance from the central vertical axis of rotation. A common central sprue and radial gates are used for feeding molten metal to the molds. Like semi-centrifugal casting, here also the mold assembly is rotated about a vertical axis, and the generated centrifugal force forces the molten metal from the central sprue into the mold cavity through the radial gates. So here the diagram of centrifuging, where this is the reservoir of feeding and a central gate is there. So different casting can be done. The mold are kept at a certain distance from the axis of rotation. Advantages is shape of casting don't carry any limitations because the axis of rotation and axis of mold are not coinciding. Because of the centrifugal force due to rotation, the molten metal is forced into the molds by means of a common sprue and gate. So here any shape can be casted. High rate of production can be achieved. Application: horizontal true centrifugal casting is normally used for making hollow pipes, tubes, gun barrels, hollow bushes, which are symmetric with a concentric hole. Vertical or inclined axis true centrifugal casting is used for production of short length castings. So these are all about the centrifugal casting.